In this video tutorial, you'll know the real capabilities of Gemini AI. What are some of the things that Gemini AI can do? I'll show you a variety of multimodal use cases that Gemini can be used for. We'll cover use cases for text and images as input, and as well as text and video as input. At this time, you can't upload videos as input on Gemini website, but I'll show you another way to do this. Compared to text-only large language models, Gemini Provision's multimodality can be used for many new use cases. Example use cases with text and images as input include detecting objects in photos, understanding screens in interfaces, understanding of drawing in abstraction, understanding charts and diagrams, recommendation of images based on user preferences, comparing images for similarities, anomalies, or differences. We'll also take a look at some example use cases with text and video as input, generating a video description, extracting tags of objects throughout a video, extracting highlights, messaging of a video. We're going to be using the Gemini API to access the Gemini Pro Vision and Gemini Pro models in the Vertex AI platform. The Vertex AI Gemini API provides a unified interface for interacting with the Gemini models. There are currently two models available in the Gemini API, Gemini Pro model and Gemini Pro Vision model. The Gemini Pro model is designed to handle natural language tasks, multi-turn text and code chat, and code generation. The Gemini Pro Vision model supports multimodal prompts. You can include text, images, and video in your prompt requests and get text or code responses. Without any further ado, let's get started. You can use your local Python development environment to follow along, or use Vertex AI Workbench and Jupyter Labs in Google Cloud. In this video, I'm going to use the latter. You'll need a Google Cloud account. If you don't have one, you can create one for free. There's a free trial. Google offers a $300 credit for new users to explore and try out Google Cloud products. Google Cloud also has a free tier which provides limited usage of certain popular products like Compute Engine, cloud storage for free, even after your trial expires. Beyond the free trial and free tier limits, you'll be charged for the resources you use on a pay-as-you-go basis. Check out their pricing for more information. I'm going to log in using a Quick Labs account, agree to the terms and conditions, agree and continue. And Google Cloud Console, navigate to Vertex AI Workbench, and the top search, type Vertex AI Workbench. This will take you to Vertex AI Workbench. Click on the User Managed Notebooks. Click on Open Jupyter Lab. Vertex AI Workbench is Google Cloud's special workspace for building and deploying machine learning models. It makes setting up your coding environment easy. The Jupyter Lab is a powerful and flexible web-based tool for writing code, exploring data, and seeing results. Think of it like a supercharged notebook for data science. It makes the development environment, creating development environment really easy. And Vertex AI Workbench uses Jupyter Lab as its main interface. I already have one here, so I'm going to click on Open Jupyter Lab. The Jupyter Lab will run in a new tab. Now on the launcher under Notebook, I'm going to click on Python 3 to open a new Python notebook. Here we can install Vertex AI SDK for Python by running the commands in the first cell of the notebook. I'm going to install the Vertex AI SDK for Python by running this command in the first cell of the notebook. Either click on this play button at the top or enter shift enter on your keyboard to execute this cell. When there's asterisk, it's working. And then when you get a number, it means it's done executing that command. To use the newly installed package in the Jupyter runtime, it's recommended to restart the runtime. To restart the kernel by running this code snippet, or you can also click on refresh button over here to restart the kernel, or you can execute this code. This time I'm going to use shift enter. I'm going to click on OK. Let's use the Gemini Pro Vision model. Gemini Pro Vision is a multimodal model that supports multimodal prompts. You can include text, images, and video in your prompt request and get text or code responses. Let's run this code in the next cell to load Gemini Pro Vision model. Let's run some code to define helper functions. These are just helper functions to display images, display and load images from URL, display content as image, display content as video, and also print the multimodal prompts that we're going to be using so that it's easy for you to see which prompt is being executed. One of the capabilities of Gemini is being able to reason across multiple images. This is an example of using Gemini to calculate the total cost of groceries using an image of fruits and the price list. Let's see the contents of our prompt. Here, we're providing the instruction. Consider the following image that contains fruits. Then we provide the image for that instruction, which is the image of the grocery. And this is the image that we're providing. Then in the first prompt, we're saying how much should I pay for the fruits given the following price list. And then we provide that price list in the image. And then we're providing the second prompt, which is the step-by-step instruction of how the model can perform this task. So let's run this code and see the output. So this is the instruction. Consider the following image that contains fruits. This is the image for the fruits. How much should I pay for the fruits given the following price list? The price list. As you can see, there are 2 bananas and I think 3 apples. There are 3 apples, as you can see. The third one is not even clearly visible to humans. And then in the second prompt, we have how much should I pay for the fruits given the following price list. This is the price list. And this is the third prompt. Answer the questions through these steps. Step 1, as you can see, this is the response from the Gemini. Is going through these steps. And the step 1 is, well, identify what kind of fruits there are in the first image. There are 2 bananas and 3 apples. Count the quantity of each fruit. There are 5 fruits in total. For each grocery in the first image, check the price of the grocery in the price list. Price of a banana is 80 cents and the price of an apple is $1.50. Calculate the subtotal price for each type of fruit. So total price for banana is 80 cents multiplied by 2, since there are 2 bananas. Subtotal price for apple is $1.50 multiplied by 3. There are 3 apples, that's $4.50. Calculate the total price of the fruits using the subtotals. And then the total price of the fruit is $6.10. Therefore, the answer is $6.10. Let's take a look at another example. Gemini can also extract information from appliance screens, user interfaces, screenshots, icons, and layouts. For example, if you input an image of a stove, you can ask Gemini to provide instructions to help a user navigate the user interface and respond in different languages. Let's run this code snippet to extract information about using the appliance from an image. So here's the code. In the code, we're providing an image of this appliance. And the prompt is, how can I reset the clock on this appliance? Provide the instructions in English and French. If the instructions include buttons, also explain where those buttons are physically located. Here's the response from Gemini. To reset the clock on this appliance, follow these steps. In this prompt, Gemini ignored to provide the instructions in French. And it does that sometimes. If you want to get an exact output, it's better to provide step-by-step clear instructions to Gemini, like the example one we did above. Let's try another example. Gemini has a multimodal capabilities that enable it to understand diagrams and take actionable steps such as optimization or code generation. This example will show how Gemini can decipher an entity relationship diagram, understand the relationships between tables, identify requirements for optimization in a specific environment like BigQuery, and even generate corresponding code. Let's run this code snippet to document the entities in a relationship and ER diagram passed to the model. Note that we're using a more deterministic configuration with a low temperature over here. What is a temperature? Temperature is the amount of creativity that is allowed for a model. So let's execute this code. So we provided this entity relationship diagram. The prompt that is given is document the entities and relationships in this ER diagram. Here in the response, Gemini mentioned the entities in the ER diagram are category, vendor, sales, convenience store, item, county. And the relationships in the ER diagram are the category entities related to the sales entity. As you can see, yes, there is a relationship, and there's one to many. The vendor entity is related to the sales entity. The vendor is related to the sales. That is correct. The convenience store entity is related to the store entity. Yep. So imagine if you provide this diagram to Gemini and asking it to write you an SQL query based on information from certain tables. It will generate the SQL query for you. Gemini is capable of image comparison and providing recommendations. This may be useful in industries like e-commerce and retail. Let's run this code snippet to generate recommendations based on a pair of glasses that would be better suited to an oval-shaped face. The prompt is, which of these glasses you recommend for me based on the shape of my face? I have an oval-shaped face. This is the first glass and this is the second glass. Explain how you reach out to this decision. Provide your recommendation based on my face shape and reasoning for each in JSON format. And the response is, in the JSON format, recommendation is glass 1, reasoning glass 1 have a rectangular shape, which is good choice for oval faces. The rectangular shape will help to balance out the length of your face and make it appear more symmetrical. I don't know if I agree to that statement, but maybe there's this fashion statement somewhere, and Gemini has been trained on it. Gemini can compare images and identify similarities or differences between objects. Let's run this code snippet to understand an example that shows two scenes from Marienplatz in Munich, Germany that are slightly different. Gemini can compare between the images and find similarities and differences. Okay, so consider the following two images. Consider the following two images, and these are the two images that are provided to Gemini. And in the prompt, what is shown in image 1, what is the similarities between the two images, what is the difference between image 1 and image 2 in terms of the contents or people shown. And here is the response from Gemini. Image 1 shows a square with a large building in the background. There are people walking around the square. Both images show the same square with the same buildings in the background. The difference between the two images is that there are more people in image 1. I guess it's right. It's just one more person here, which is not present over here. Now let's transition to use cases with text and video as input. Gemini can also extract tags throughout a video. Let's run this code snippet to generate a video description for a sample video. Let's take a look at the video that was provided to the Gemini. This is the video. The prompt is, what is shown in this video? Where should I go to see it? What are the top 5 places in the world that look like this? And the response, the video shows a harbor in Turkey. The town is called Kos and is located in the Mediterranean coast. The video was taken from a drone and it shows the beautiful scenery of the town and harbor. The top 5 places in the world that look like this are Cinque Terre, Italy, Positano, Italy, Amalfi Coast, Italy, Saint Tropez, France, Mykonos, Greece. Gemini can also extract tags throughout a video. Let's run this code snippet to extract tags of objects throughout the video. Okay, this is the video that is provided. Please note that we are providing video and text as input to the Gemini model. Let's see the video that was provided. This is the video, and the prompt was provided is answer the following questions using the video only. So in the prompt, we're asking the model to use the video as reference for these questions. What is in the video? What is the action in the video? Provide 10 best tags for this video. And the response, this is a response from Gemini model. A man is taking a picture of a table. The table is decorated with a variety of objects, including a vase, a bowl, some candies, candles. The man is wearing a hat and a casual outfit. The room is decorated with a variety of objects, including a chair, a rug, and some artwork. Here are 10 best tags for this video: photography, home decor, interior design, rustic, lifestyle, travel, vacation, Mexico, Tulum, Casamalca. Okay, pretty good. Now let's ask it more questions about a video. Okay, this code snippet is an example of using Gemini to ask questions about the video and return a JSON response. Let's run this code. Okay, so here's the prompt. Let's run the video.
島田彩花です。東京でフォトグラファーをしています。東京にはいろんな顔があって、夜の東京は昼の東京と全く違うと思います。新しいピクセルには動画ブーストって機能があるんですけど、暗いところだと夜景モードが作動して画質がさらに上がるんです。三茶は上京して初めて住んだ思い出の場所なんです。いい感じです。お、綺麗。次は渋谷に来ました。みんな。
Answer the following questions using the video only. What is the profession of the main person? What are the main features of the phone highlighted? Which city was this recorded in? Provide the answer in JSON format. Okay, so this is the response. The name of the person is Saike Shimada. I guess it took it from the subtitles there. The phone brand is Google Pixel 8. The features are Video Boost, Night Sight. City is Tokyo, Japan. Let's retrieve extra information beyond the video. This code snippet retrieves extra information. Let's run it. As you can see, Gemini is still generating its response here. Okay. The prompt is, let's first watch the video. It's a 20-second video. As you can see, this is the line for the train. And the prompt is, which line is this? Where does it go? What are the stations and stops? Okay. This is Ottawa Confederation Line, also known as the Trillium Line. It is a light rail line that runs from Tunis Pasture to Blair. The line has 13 stations and is 12.5 kilometers long. Okay, so which line is this? Answer that. Where does it go? Also known as runs from. Okay, and the line has 13 stations. The line. What are the stations and stops? Well, it's not telling me exactly what stations and stops, and it's not showing which country is this. So let me try to run this code again and see the response. Okay, now it's much better. Okay, the Confederation Line is a light rail line in Ottawa, Ontario, Canada. It is operated by OC Transpose and connects Tunis Pasture to Blair. The line has 13 stations and is 12.5 kilometers long. The Confederation Line was opened in 2019. It has been a popular addition to Ottawa's public. The line has helped to reduce traffic congestion and made it easier for people. It's still not showing me the stations and stops, but it's got most of the information right. So, okay, let's move on. All right, that's it for this video. You have explored a variety of multimodal use cases that Gemini can be used for. I read all of the comments and I'd love to hear your thoughts. Please feel free to share your ideas for upcoming videos. If you don't have any question or suggestion, you can support my work just by typing Coding Money in the comments. This really helps with the YouTube algorithms. If you found this video useful, a thumbs up would be highly appreciated. Stay tuned for exciting new videos. To ensure you don't miss out, please subscribe and hit the notification bell icon. Until next time, thank you for watching.